Now we will talk about the section 8.4 electrolysis of brine. See, the brine is nothing but a concentrated solution of sodium chloride. So you know the importance of concentrated solution of sodium chloride. See, the electrolysis of this concentrated sodium chloride solution, you know, it will create Na plus and hydrogen gas, then chlorine gas, and then you know the solution will be, electrolyte solution will be the container. It will changes into sodium hydroxide, and okay. And yeah, so you can see this hydrogen, chlorine and sodium hydroxide all are useful products, and all are having some particular uses are there. Okay, and so what you can understand about this is, see, now we will see how is the setup used for electrolysis of brine. So it will be something like this, and there will be a membrane separating each other. So there is anode as well as there is cathode. So this is this is going to be anode. Anode, you know, anions shall be going to anode. So anions are having negative charge. Remember that anions are having negative charge. So obviously anode is having positive charge. And this is a cathode. So cations will be going to cathode. Okay, so since cations will be going to cathode, this cathode is going to having negative charge. See, actually the anode material what we uses is it is nothing but titanium. Actually titanium will be using as anode, and here the cathode material is supposed to be it is actually nickel. Okay, nickel anode, nickel cathode. So let me write it again. So this is anode, this is cathode. Actually this membranes allow the passage of Na plus ion and OH minus ions. Okay, so these are porous membranes, what we call it as a porous membrane, because it is having porosity will be there. So this membranes allow the passage of Na plus and Cl minus ions. Okay, and this from the solution, from the left side in the anode, you can see actually like what are the anions here. In the anions, the Cl minus anion, Cl minus will be going to anode, and obviously Cl minus, so it is going to be Cl2 plus 2 electron minus. Okay, and H2 and cathode, like in cathode, H plus 2H plus 2 electron gives H2 gas. And yeah, so this is the reaction it is happening. So from the anode, chlorine gas will be going, and from the cathode, hydrogen gas will be going out. Okay, and chlorine gas and hydrogen gas will be going out. And yeah, so this is and through this outer porosity, sodium hydroxide solution, concentrated sodium hydroxide solution, it shall go out. See, now we will go into the importance of electrolysis of brine. As I told you, see, every product in the electrolysis of brine, what can generate in the anode, what can generate in the cathode. Okay, every product in the electrolysis, it is having some significance. For example, hydrogen gas. Okay. And see, nowadays hydrogen is one of the very good fuel, because if you check it, if you check in the whole of the scenario, whole of the global scenario, hydrogen is one of the well researched area. Past 10 years back when I am looking, actually the most of the countries they have funded heavily for the production of hydrogen, either through electrolysis, mostly through electrolysis or through some other methods like pyrolysis or whatever it could be. Hydrogen, the reason is 1 kilogram of hydrogen, its energy density is going to be very high. Suppose if you take 1 liter of petrol and you are taking 1 liter of liquid hydrogen, 1 liter of liquid hydrogen, this liquid hydrogen's energy, how much energy it can store, that is going to be very tremendous. Okay, that is going to be excellently tremendous. at least 10 to 20 times more than what the energy of petrol or diesel. Okay, so this is the reality. And moreover, hydrogen is a very lightweight fuel. Okay, lightweight in the sense, 1 liter of petrol, you will be taking like this, but 1 liter of hydrogen you can take like this. In a very, that is the power, that is the beauty of hydrogen gas, right? And other applications of hydrogen could be, for making, for making hydrogen peroxide. Hydrogen, it combines easily with oxygen. It forms H2O2. Of course, it forms water also. Of course, this reaction, it is going to be using some catalyst. Okay, and probably another use is in making a nylon. You know the polymer nylon, right? So in making the nylon polymer, so we use hydrogen gas, and hardening of vegetable oils. Okay, hardening of vegetable oils. So okay, so these are some of the core applications of hydrogen. And remember one thing, hydrogen's most important fuel application. It is a rocket fuel nowadays, in the past itself, but subsequent time, in your lifetime itself, in next 10 to 15 years, and then 10 to 15 years, you will see the vehicles will be running with the hydrogen, because that is a tremendous, that much of research, that much of development has happened, and it happening and will be happening in the development of hydrogen as a fuel. It is a very strong explosives, and one of the challenge still pertaining for the use of hydrogen as a fuel is, okay, see, once a hydrogen blast happens, a big building even collapses. That much is the strength of hydrogen collapse. Hydrogen, that is a problem when how we can use hydrogen, and probably these problems will be circumvented by our great scientists. Okay, next we will see the uses of sodium hydroxide. Sodium hydroxide, yeah. Next compound is sodium hydroxide. See, you know very well sodium hydroxide, how it appears. It is a translucent. Translucent means, see, when this glass is a translucent, because of course this glass is a transparent, but if you increase the opacity, like only little light it will be passing through the glass. Okay, and so what you can understand about the glass is, okay, it allows the passage of little bit of light, that is called a translucent, right? And sodium hydroxide, it uses in multiple applications. Okay, it uses in the making a soap and detergents, soaps, detergents. In fact, soap, it is made from sodium hydroxide. Sodium hydroxide, it is one of the component. Like fatty acids, it will be treated. If you treat sodium hydroxide with the fatty acid, this is going to form soap. Okay, and of course the detergents, and then like a nylon. Nylon is a polymer. Nylon, for making polymer, we use a soap. We use a sodium hydroxide, and then like a dyes, and then you can use medical drugs. Okay, so you can use medical drugs and different stuffs. It is for so making these are the things, it uses sodium hydroxide as one of the steps, one of the component for making it. Then next one is chlorine. Chlorine gas, as it is a greenish yellow gas. Okay, it is a greenish yellow gas. So chlorine, it is one of the disinfectant, and it is one of bleaching powder. Okay, it is a bleaching powder, and it is one of the, it is for making polyvinyl chloride. Okay, it is for making PVC, polyvinyl chloride. It is a polymer, and now it uses as paint and dye stuffs. Okay, it uses in making paints and dye stuffs, and then of course hydrogen chloride. hydrogen chloride. Okay, so these are some of the applications. See, chlorine is a very corrosive gas. If you inhale it, you will be coughing, and it is a very dangerous gas also. Like if a person continuously prolong to the exposure of chlorine, then he will be succumb to cancerous conditions. And now next thing is next gas is hydrogen. Okay, so hydrogen, you are well familiar. What are the applications of hydrogen? Okay, so I will write it here. So hydrogen, it is a fuel. It is the fuel of future. Once upon a time, it is the fuel of future. But now I can tell you, it is becoming the fuel of future, fuel of present. It is becoming the fuel. So it is one of the very good fuel because its fuel value and calorific value, as I told you, it is very high. Okay, and it uses in the hydrogenation. Some applications it uses as a hydrogenation purpose. Actually, hydrogen, it is a very strong explosive. See, if it explodes, the very exponentially, the blast will be happening. And on the other hand, if you ignite a petrol or diesel, how it will be? It will simply ignite. Nothing else will happen, right? And other applications of hydrogen, it is. It is using in the hardening of vegetable oils. Okay, hardening of vegetable oils and okay, and so these are some of the applications, right? Okay. And this whenever we are transporting the products of electrolysis of brine. See, what are the products of electrolysis of brine? Chlorine, sodium hydroxide and hydrogen. Okay, whenever we are transporting, we will take a very extra care because see, you can see three products. Hydrogen, it is a very strong explosive. Once a hydrogen cylinder explodes, that whole area will be devastated. Okay, and that sodium hydroxide is again, it is a very corrosive stuff. If it spills into water bodies and that solution will become alkaline. Many vegetative problems can come, and apart from that, if it goes inside our stomach, maybe if sodium hydroxide goes into drinking water and that will create a big problem, and you will be in the person may even succumb to death. Chlorine, it is a very corrosive gas. It can create many harmful conditions. Okay, it can create many dangerous conditions. Okay, so these are the problems with the chlorine, hydrogen and sodium hydroxide. So the extreme care will be there when we are transporting these steps. Okay, thank you.